We're going to discuss ground penetrating radar today, used for density control and hot mix surfaces. Just to give a little background on GPR use in Texas. We've been using it for the last approximately 20 years. We use it for work in the early 2000s through 2010s to validate whatever our concept was for the pavement. In the Waco district, we use it for all of our 4-year planning, and there's the picture of the GPR van as it is now. The GPR, as we use it now, measures dielectric constants as a function of volumetrics. There's just a sample trace in how it measures the dielectric constant by the amplitude of the wave. And for the discussion here, we're just using the surface readings. So for the first poll, based on our current minimal testing requirements found in the TxDOT specifications and the testing guide schedule, what percentage of a 2-inch hot mix is represented when we test for density for acceptance of that lot based on density and air voids? And that's based on area of what we core now. So the answer is A, it's 0.001%. So based on 4 sublots and 8 cores, we're basing our acceptance of the hot mix sublots based on 0.001% of the area measured. I don't know anybody with TxDOT or the contract community that is comfortable with that. You know, from TxDOT's end, we don't know if we're testing just a few random spots that happen to be good, and we may be missing a lot of bad spots. And on the contractor's end, we may test one bad spot, and their concern is that we're testing one bad spot, and the rest of it may be fine for 250 feet, and we tested the one bad 20-foot spot. That's not good for anybody as far as I'm concerned, which is going into why our new research into the rapid density measurement device comes in. So the benefits for using GPR for density control, there's no licensing associated with it like it is now with the nuclear density gauge. And I don't know about you, but I don't like when the health department has to come and inspect us, because depending on what day you catch that person, if they're 2 days from retirement or if they're brand new, can determine how good or bad of a day you're about to have. So the rapid density measurement has it's a rapid turnaround time, which minimizes disruption in your operations. It's increased testing coverage, which is basically 100% of your pavement mat, and reduces the acceptance risk for the contractors and TxDOT. This promotes a more uniform, longer-lasting pavements, and that's what we're all about. I know at TxAPA conference a couple weeks ago, that was repeated multiple times by everybody speaking, both on the contractor and TxDOT end. So going into the other potential benefits for GPR and density control. So the early testing, we had to test it with the GPR, run it through multiple programs to get to the color map that you see there. The new method is by this one device which has the computer mounted, gives the reading. It's all internally real-time based data processing and integrated analysis modules. So we had a implementation project in Waco, 2 different projects that were adjacent to each other. So there were 3 days of paving. The first day we calibrated the system, and days 2 and 3 they ran QA testing behind the machine. They ran testing for the rolling density meter, the nuclear density gauge, and then they cored. The coring was done also for calibration of the rolling density meter, and right now the method is to core, calibrate the day's paving, and then continue with your QA testing. we're trying to, TTI is trying to go to a method of testing the raw materials and see if they can get measurements off of that and calibrate off the raw materials going into it, and then plug in whatever the rice density is for that day's production and get a calibration off of that instead of coring multiple places and making Swiss cheese out of the pavement like we do now. That's the whole part of the point, is to get away from doing that. There's the project locations. It's on State Highway 6 in Waco, just off I-35 once you go past US 84 and going over the Twin Bridges past that towards Valley Mills. That was our thin overlay mix, which is now finished. And then the data that you're going to see on the next few slides, they're from just a regular Type D overlay that we had for a Super 2 project. So the day one calibrations for this testing, you can see it here. For the Tom mix, the R value is very high, very good R value of 0.89, as well as the dense graded mix of 0.91. So this is the view of the, let's see. So this is the this is the readout of the device that you saw on the previous, that's the readout from this device. And as you can see, in our regular testing, we would probably test somewhere, within this first quarter and then the next quarter, and then so forth and so on and so forth for our normal density requirement testing. And if we took a test right there, that means that we would reject the entire sublot of mix. We'd have to mill and inlay because we took a test right there, probably where a paver stopped, and we couldn't get density. So, on the contractor's end, this is what my biggest complaint I get all the time is that, well, you're testing right there. That's one bad spot. We don't think it's, we don't think that's fair. Well, that's part of the spec, unfortunately, right now, and that's what we're working on changing. So, as you can see, this is something that'd be very beneficial for TxDOT and contractors alike, because it gives you a true overall measurement of the pavement surface and your paving mat for that day's production. As a contractor, you can see things where your rolling pattern, maybe your roller got tired at the end of the night and stopped paving and stopped way back here and then got back on this mat whenever it was too cool. So you can improve your rolling patterns based on what you see and measurements that can happen, within minutes of paving. As fast as you can get that machine on there and get the inputs in, go back and evaluate on your computer that you got there on the job, you can make corrections there, the same day, as opposed to waiting for 24 hours for the cores to dry and then waiting for another 12 hours to get the results whenever you come back to work the next morning. That's not beneficial to us out in construction. So the outputs can come into our Excel spreadsheets, and you can get a histogram. So the green locations, I believe these are the maximum bonus, and this is bonus, and then penalties, and then remove and replace locations. It's supposed to be red, but it doesn't show up too well up there. As you can see, the weighted pay factor for the average of all the mix would be a 1.022, so the contractor would get a bonus overall based on the average scores for the pavement. If they went through a measurement method of going by a certain percentile, then based on like a 95th percentile, you'd come over to somewhere in there and get a percentile weight based on whatever our spec may be into the future. Let's see. And this is just another chart showing the air voids using for our Tom mix, because it's not density. There's no density requirements on Tom as far as field densities. We just go by water flow test, but the void content is closely related to flow time, so we could possibly write a spec once we know a little bit more about Toms and what the characteristics are compared to regular dense graded mixes or SMAs or some of our more familiar mixes that require densities on the road. So up here, this is day one calibrations for the entirety of the testing for the 3 days, and you can see the R value is 0.67, and follows pretty closely to the one-to-one line. But then if you use daily calibrations for testing, you can see how much tighter it gets. And that's what TTI is trying to work on and figure out how to get a better method of calibrating their machines to try to get the best result. Because, like I said earlier, taking densities of the cores every night, that's going to slow production. It's not much better than what we're doing now. And you know, we're wanting to get as much information as possible before the contractor starts to roll each night. This is just showing what the R value is for the nuclear density gauge. So you can see, based on this, that's not very good, considering, you know, we have to have nuclear density gauges licensed. We have to go take the cores back into the lab for acceptance. The method that they're using, the rolling density meter, the rolling density meter has much better results. It's quicker. It's better for TxDOT. It's better for the contractor. And we seem to be on the right track with this device. So future visions and needs. There's going to be a vehicle-mounted option hopefully pretty soon. We want to try to define the optimal calibration methods, like I talked about, and try to develop some type of approved test method. So ultimately, what we're saying is we don't want to try to do nothing. There's no reason why we keep doing the same thing over and over and over again, year after year, when we know there's better methods out there, and TTI is working towards that. So, you know, we don't want to have Michael Scott's philosophy of do nothing ever, no matter what. We want to change. We've got technology out there that is beneficial to everybody. You know, we preach safety and keeping the contractors off the road, having quality pavements is beneficial for us, since we don't have to spend the money year after year on the same roads. The public perception of having long-lasting roads where they're not driving through constant construction projects, and allowing the contractor to produce those good performing mixes and make a profit, because those are all things that go into these quality pavements. So I guess the big question is how do we want to identify a possible implementation, and what specifications do we want to do in the future? You know, do we want to have kind of similar to how we used to use the pay-by-hour bar? I know it was like pulling teeth to get the contractors to use that pay-by-hour bar, because they kept saying, you know, y'all are going to fail the mix, you're going to fail it, you're going to fail it. We don't want to put it on there because that's all you're going to do. You know, part of this is trying to get them to use this device and try to see if we can get some type of, you know, feel for what really needs to be done and how we need to proceed in the future with this research. You know, pay factors with percentages inside the density limits, or based on a percentile, or some other method. My option, or my preference, would be something probably B, just based on taking that overall performance of the mix, and then if we had remove and replace sections, deal with that as they come. Like in that previous slide. So I guess the big winner is B, but if we go back, my option would be, if we have a certain length of roadway that is here, you know, say if it's over 100 feet, then it's going to be remove and replace. If it's less than 100, there's no use of going out and having the contractor remove and replace a mix when it's just going to create a bump. It's going to create more issues with that one location. You know, probably have a no pay for these small sections, and then go on with the road and you know, fix the problems if they come up. So I know I went pretty fast in here, and I want to make sure there was time for discussion. Stephen Sebesta and Brian Wilson are the TTI researchers that are working on this project. They can do a lot better justice than what I did, and get a lot more into the research and technicalities of the density device. So I put my kids up there because I gave the presentation, so I get to. And then that's my new bird dog, so he still finds it fun to go chase birds in 95-degree heat, so we're good to go for a while. Are there any questions or discussion? Yes.
I'll preface it by saying I worked with Tom many years ago and found even with the map that's already been placed and under traffic for, I don't remember the period of time, but a significant period of time, it was very easy to identify segregation, bat-wing segregation, familiar with Truffian compass segregation. You can see if they're stopping the paver and dumping the wings. I would suggest, as far as implementing it, and I would like to see us combine it with the IR bar. You know, both of them maybe introduce a period of time where we don't really penalize them or even bonus that heavily, but say they've got to use the devices, get the data, see what's reasonable. And I would also go so far as to suggest that if we've got a place out there where we don't have a density requirement or we've got segregation, we don't want that. And I agree with you, you don't want to be trying to patch little bitty places, but to me, we need to make penalties significant enough where they will have a continuous operation and eliminate, and have the proper rolling method to eliminate the segregation and lack of density. And I've seen good contractors that don't have a problem with it, they use the IR bar, they don't even question it, and they use it for their own benefit. So I'm personally, I'd like to see us get that way instead of worrying and wrenching our hands about whether the community will accept it.
Right.
Tell them they've got to use it, maybe give them a period of time where they can see what's happening and get a feel for it without penalizing them that hard, but get to the point where we actually have enough buy-in in there that it encourages them to eliminate these places that segregation occurs, typically because of stopping the paver, dumping their wings, or improper rolling methods and so forth.
Right. Yeah, and that, yes.
Could you summarize that?
What he's saying is that we need to implement some type of incentive for the contractors to begin using this, maybe at no penalty, kind of entice them to for us to get, well, right, for just informational purposes and not kind of like we did with the Pave IR bar, and force them to use this. And then once the contractors have a better feel for this, then have the requirements set up to where, you know, kind of similar to what we have now with our density requirements, and say, this is just what we're going to use. This is part of the spec now. This is what our requirements are. There's also a big push from what Stephen was telling me, from the feds to start using intelligent compaction, Pave IR bar, and this RDM all in conjunction. And I really think this is probably the way of how we're going to be doing things in the future, because once you combine those three things, you really don't, you have very little room for anywhere to make any kind of mistakes. I mean, if you've got intelligent compaction, the Pave IR bar for your temperature requirements, and then your RDM measuring your density, that's going to give you a superior pavement as long as you're using all three of those things in conjunction with each other. There's also some the readouts for the program that we have. Stephen said that we've only been using that program for about 2 years, so they're improving the program, and that's one of the things they're working with on the material, the person building those devices. So they're working on that, so they're going to have better input. It's just like the Pave IR bar. I mean, I remember when they started with that, it was just a chart, and now they have full-blown graphs. So what TTI really needs is TxDOT districts to answer the call whenever they have requests for projects. And I know they're trying to find different types of hot mixes or different types of hot mix with different types of aggregates to use in this, because I believe they've just been using limestone, as far as I know. And Tom, you may know, but as far as the pavement engineers, I know we get requests all the time for saying, if you have any of these types of projects going on, you know, come out. Well, all they did was come out and tested, and they weren't in the way of the contractor. They didn't get in TxDOT's way. They ran their tests. They got off the same time as the contractors did, and you wouldn't even know they were there. So all this is going to help out TxDOT in the future, as well as contractors alike. So I just encourage y'all to do this and help them out any way you can, because, you know, Waco is not the same as Laredo and not the same as Lubbock or even further northeast Texas. So the more data they have, the better off we're going to be in the long haul.
Also, would be interesting to see if there's any correlation in the IRR and really type of incident meter, because typically if you've got thermal segregation, that's going to lead to lack of density.
Right. Rich, do you have a question? Okay. I'll have to push that to Tom. 2 gigahertz is what he said. Oh, I'm sorry. They asked. Rich asked what the frequency of the GPR was and the cost, and what the cost was. Stephen said that the system is around 30,000. I guess so. In closing, I kind of made my closing remarks. So, you know, try to help out the researchers. You know, whenever they ask for help. I know Waco's been helping them out, and I like seeing this research because, you know, any kind of additional information we get, it's going to help our projects out and have our pavements perform as long as possible, and allow us to not have to get back on those roadways. That's all I got. Oh, yeah. Yeah. $1 a square foot. Yeah. Yeah. Okay. Yeah. What Tom said is that nationally there's a lot of interest in this, and there's a national national research project going on or trying to get implemented. Right. It's going on right now. Up in Alaska, they're actually concerned about joint density because of their the failing of their joints, and their cold weather causes a lot of joint failures. And they're going, instead of just a mat density, they're going with joint density. And I believe they give like $1 per linear foot of bonus if they have good joint densities, and it's within a certain requirement. So I don't think we have a lot of joint density issues statewide in Texas. I mean, it's debatable sometimes, depending on which part of the state you're in. But that's another route to go if we start giving some type of bonus for joint densities as well. You know, it may start out as bonus for joint densities, and then once it gets implemented further, maybe we can get away from having to give bonuses, and it's just part of the project, part of the specifications.